In this example, we are going to find the real and/or imaginary solutions to this particular polynomial equation. If you've been pretty well prepared to deal with all types of factoring, you should recognize that this example here is the sum of two cubes. We have 27x to the third plus 125. In this, it's not just a polynomial expression, but it's actually a polynomial equation. When you have an equation, your directions won't just say something like factor or expand or simplify. Instead, the directions will somehow imply that you need to be solving or finding a solution or an answer of some sort for the variable in the equation. So you want to make sure when you see an equal sign or any other prompts in the question that would imply that you need to solve, that you do so. A lot of people will just stop at factoring, or the opposite is true, where you have to just factor something and people will magically set it equal to 0. So don't do that either. So hopefully we all know that the way you solve a polynomial equation is you initially begin by attempting to factor. And if we can get things factored as far down as we can, ideally to linear prime factors, we use something called the zero product property. We set each of them equal to 0 and solve for x. In the event that we hit up a quadratic that cannot be factored, we can use the quadratic formula, which we derived by completing the square. And we can use the quadratic formula on that. And some of us already experienced the lesson on imaginary numbers or complex numbers, so we will go into that. So it depends where you are in your curriculum. If you already know about imaginary numbers, you're going to be able to fully grasp the final ending of this problem. If you have not addressed imaginary numbers yet, then you would get to a certain point and probably just put no real solutions. Okay, so let's dive into this. We're going to get this factored. When we look at this, we need to recognize what's being cubed in each of these two expressions right here, the terms rather. So 27x cubed, I'm looking through my magical cubing glasses. What was being cubed so I can use my x-ray vision? So this would be 3x and this would be 5. You should know the cubes up to maybe 8, 9, 10-ish, 11 by heart so that you're able to fly on these, right? Then we end up having one linear binomial factor, and in this case we're going to have one quadratic trinomial factor. Don't lose your equal 0. The linear binomial is actually equal to this expression up here if you were to take away those little cubes. So we're going to take those 3s, we're going to put them in our pocket, and we're going to write down 3x plus 5. Then we're going to use the 3s in our pockets to do a little magic and sprinkle some fairy dust on our paper. What's 3x times 3x? Well, that's 9x squared. What's 3x times 5? 15x. We're not doing any signs over here. And what's 5 times 5? That's 25. So we have a linear binomial, and we also have a quadratic trinomial, but we need to figure out these signs. So we sprinkled our fairy dust, those 2 3s sprinkled into 3 and 3 sprinkles of magic fairy dust to help us figure out the quadratic. We've got to clean that glitter off our hands. And what do we use to clean our hands? Of course, we use soap. S-O-A-P. S-O-A-P, our mnemonic device over here. We've been doing another 4-letter F word mnemonic device, foil. Maybe we need the soap to clean out our mouths because we had a 4-letter F word that was very bad. Same sign as the problem. O is for opposite of that sign, always plus. I know some people say positive, but I feel like it's more of a plus when it's in an expression like this, not just positive. And also plus has fewer syllables. Why are we trying to make more work for ourselves, you know? Now we just got to finish this up. This is a linear prime factor, so we're going to start that zero product property and set this equal to 0. We're going to subtract 5 on both sides. So here it's gone. This is a case where we could say it's canceled. And here we have just -5. Then we're going to do the inverse operation of the multiply by 3. We're going to divide by 3. So we get x equals -5/3. Leave that as an improper fraction As long as it's reduced, we're good to go. That is our only one real answer. Now here, this is a prime quadratic. It will be a prime quadratic every single time you get the quadratic from a sum or difference of cubes factoring problem. This will not factor, so we have to use the quadratic formula. If you've watched all of my videos on solving with imaginary numbers, I definitely go over a trick or shortcut in one of my older videos on how to do it when it is the imaginary number situation, specifically this one, the quadratic from a sum and difference of cubes. I do have a very, very, very wonderful shortcut hidden in one of those videos, so if you want to go dig it out, you could probably find it. But let's go ahead. X equals negative b plus and minus the square root b squared minus 4ac all over 2a. A is 9, b is negative 15, and c is 25. So let's go and fill those in. X equals negative b is 15 plus minus the square root of b squared. Really, it's negative 15 in parentheses squared, but it kind of doesn't matter because when you square a negative or a positive, it's going to be positive. And that's going to turn into positive 225 in the next step. Minus 4ac. Make sure that square root covers everything nicely. All over. If your fraction bar does not go where I'm drawing mine, you're wrong, okay? I'm just going to tell you right now. You're wrong. You're doing it wrong or incorrectly. But like, don't even bother then. Why are you even bothering? Draw it all the way across or don't bother. All over 2 times 9. Now, cleaning it up some more. So let's see what we could fit. So 15 plus minus the square root of, okay. Negative 15 squared is 225. 4 times 9 is 36. 36 times 25. Actually, let's do this. 4 times 25 is 100. Oh my gosh. 100 times 9 is 900. That was easier. All over 18. Oh boy. Running out of paper and have a barky dog. So we're here right now. Now we need to simplify 225 minus 900. So what we would do in this situation is you do 900 minus 225. We're going to make the answer negative. So 900 take away 200 is 700. And then take away 25 more, we're going to get 675. So I'm just going to go up and around. X equals 15 plus minus the square root of negative 675 over 18. Now, if you didn't learn about imaginary numbers yet, hopefully you're aware of the fact that you cannot take the square root of a negative number. So at this point, we would write no real solutions, but no real solutions from this part of the equation. Of course, we got one real solution over here of negative 5/3, but we have listed that we can find our real or imaginary solutions. So let's keep going. If you learned imaginary numbers, you hopefully will get the end of this. Either way, though, if you're doing something like this, that means you probably already took geometry and you should know how to simplify a radical. So 675, I'm going to make a little factor tree with that. Looks like 25 goes in there. 25 goes into 100 4 times. So 25 goes into 600 6 times 4, or 24 times. And then 1, 2, 3 more for the 75. So that's going to be 27 times 25. So 25 goes into 100 4 times. So if we have 6 100s, that's 6 times 4, 24. And then 3 more to get us to 625, 650, 675. I hope that makes sense. Here we have 5 and 5. And here we have 3, 3, 3, right? So when you simplify a radical, it takes a pair to make a square. So if we're doing a square root of positive 675, we're going to make believe, well, we would take a pair of 3's, that's really 9, right? And we're going to take that out as a 3. Square root of 9 is 3. Okay. Take a pair of 5's, take that out front, because that's really 25. Let's square root of 25. Well, that's 5. So 3 times 5 would be out on the outside, and a 3 on the inside, so it's 15 square root 3, right? Right. But what's going on? We have a negative. The square root of a negative 1, which is sort of floating around in there, is the imaginary number I, or the imaginary unit I. So what do we have? We have 15, put a little equal sign in front. Don't look like a negative. 15 plus minus 15 I square root of, so the negative's taken care of, most of it's taken care of, 3, which stays inside, all over 18. And now we're going to do a little simplifying. Let me try to grab a decent pen or marker. How about this one? We're going to reduce a little bit over here, and we're going to reduce a little bit over here. And doing something like this is from all the way back in lesson 4. Dividing, simplifying, and reducing when you have a polynomial over a monomial. Well, same technique. What can I reduce over here with 15 over 18? They both have a 3 in them. Good. So that'll become a 5. Get a 3 out of that and a 3 out of that, right? Both divide by 3. So we have 5 plus minus 5i square root 3. Take a 3 out of this. What's left? 6. So that's still x equals and x equals. So we have two imaginary solutions here. We have 5 plus minus 5i square root 3 all over 6. I know it's gross, but we got two imaginary or complex numbers right there. And then we had one real number or real solution, and that was over here, negative 5/3. And that, ladies and gentlemen, is how you would find both the real and imaginary solutions when solving an equation which happens to be in the form of the sum or difference of two cubes. Hope that explanation was great for you, and I hope you can apply this to another sum or difference of cubes equation on your own. Good luck, and to see another example on this big review of polynomials, you can click on the box on the screen.